So our first module is introduction to antennas. So in this, I'll start with the antenna mechanism. So key highlights I have mentioned here, that is antenna mechanism, threats of radiation, or you can say the drawbacks of radiation, and SAR, that is specific absorption rate. So what is antenna? So antenna is nothing but a kind of electronic device which is having a feature of transmitting and receiving the radio waves, or you can say converting electrical energy into electromagnetic energy in the form of radio waves, that is, and performs a successful process of transmission and reception of the EM fields or EM signals. And one more standard definition has been given by IEEE, that is Institute of Electronics and Electrical Engineers, which is having a definition as a means of radiating and receiving radio waves. Radiating is nothing but transmitting only, because the waves will propagate. So this is also one kind of a definition which is given by the IEEE. So this is the block diagram for the wireless communication. In the first image, I have created a rough diagram for the transmitter, and in the second block diagram, I have created a receiver antenna, receiver wireless communication block diagram. So as we know that message, whatever we are sending the information, so information is nothing but a low frequency signal. So that's why we'll say as a modulating signal, and to take it along to the receiver, we need some another signal which is of high frequency comparative to that modulating signal or the message signal, that is called as a carrier signal. So carrier, as the name only suggests, we can know that from carrier signal only we will take that message signal to the receiver. So this imposing of that message signal into the carrier signal, we all know that is process is called as modulation. So that is performed by the modulator device, and further it will amplify the signal so that it can sustain the noises, interference, distortions. And regarding this modulation operation, some of the signals will get deteriorated, and so that's why also amplifier is needed. And in the last side, impedance matching network is needed. So this topic, one topic I remember that came in my mind, so I'll explain it now only, that maximum power transfer we all have studied in our electronics academic, in a academic time when we are doing our graduation and all. So at that time we have studied that maximum power transfer will happen once the when the so load resistance is equal to the source resistance. Okay, or I will say load impedance is equal to the source impedance. So that's why that is maximum power transfer theorem only. So if it is equal, then only the maximum power transfer will be take place, and hence otherwise the losses will occur, and at that time we will be having a losses, huge losses, and will not able to transmit more power, more signal to the environment, or you can say that to the receiver side. And in the receiving side, if I'll come, during the receiving of signal, first of all we have to we have to take a RF amplifier, or you can say simply RF amplifier only, because we are receiving a radio waves. So that's why RF amplifier is needed. Then further it has to be mixer. It will be goes to mixer, which is having a local oscillator. Now this local oscillator is synchronized to the carrier signal, means whatever the frequency is used in the carrier side, that same frequency is used on the local oscillator as well, so that the demodulation operation can be attained successfully. And further, this IF filter and amplifier is there, which is again nothing but the intermediate frequency filter, which will perform a fs minus fm, or you can say fs plus fm to frequency it will take off for the sampling purpose. And further demodulator will take place, and for the display device, or you can say the user device, the signal, or you can say signal will be shown to the display device or any other user device. Okay, so this is nothing but a wireless communication block diagram full, that is of transmitter and receiver simultaneously. It is a very rough diagram. There are more complex and complex diagrams can be done at in a commercial way as well, or in an academic purpose as well. We used to study a lot regarding these wireless communication, and especially if any one of you have done your your masters, then definitely this specialization of communication, and that too in a communication specialization. So he must be knowing what is the complexity in this wireless communication. Okay, now the next is the electromagnetic spectrum, because anyway any antenna which is resonating, which is transmitting radiation, so it has to be some signal at some frequency. Okay, so suppose if I am taking an example of any of the application like Bluetooth also, so has to be resonate at 2.45 gigahertz, and in case of Wi-Fi also, suppose 5 gigahertz and 5.2 gigahertz and 2.5 gigahertz, these are the bands. So these are the nothing but the frequency only on which the antenna has to be made. Okay, and further in case of your television, if you are using, then in that time we are using our remote. So remote is emitting a frequency signal which is not having any antenna, but it is having a signal which is comes under the infrared region. Okay, so infrared region, we all know what is the frequency range, and anyway I have mentioned already here the wavelength range. Okay, so that you have to see, not do not need to confuse with the frequency or the wavelength. Okay, so as you can see in this also, the first line depicts as a wavelength in meters, which starts from 10 to power 3 to ranging to 10 to power minus 12, which is far far shorter. Okay, now accordingly, this size of a wavelength, what will be the size of the wavelength, as you can see in 10 to power 2 means 100 meters. 100 meters can be of a football ground, or you can say the soccer ground. And further, as the size will decrease, so accordingly some small sizes have been taken, some small uh, things have been depicted here, like a cell, unit cell, or you can say the bio cell. Further, the bacteria, which is comes under the 10 to power minus 6 wavelength size. In terms of size, they are trying to depict it in this case. Okay, and further, each of these range is having some names. Okay, which is named as radio waves, microwaves. Microwaves generally start with the 1 gigahertz. Okay, and for the infrared region, ultraviolet, and in between this infrared to ultraviolet comes as a region of visible region, which is for which means for that for a human eye we can see these different colors, different wavelengths. Okay, with the human naked eye. And further we are having a x-rays also, and in that also some radiation range is there, which is a soft hard x-rays and hard x-rays. And at last we are having our gamma rays, which is nothing but used in the case of nuclear reactors and nuclear weapons in this case, such as in nuclear power plants. Now for these frequencies, what are the sources, means what are the devices which emits such frequency range? So that also it has included, which is the sources, means am radio. Am radio will transmit a longer wavelengths frequency, which is having a longer wavelength. Okay, And further, this FM radio, that is frequency modulation radio, then microwave oven, and radar antenna, or you can say the military radars or ATC. This airports are having nothing but ATC only, which is air to control. So these are also having radars in it. And further, people which are emitting the rays, also people humans can also emit the rays in some different forms. And further, light bulb, these are all comes under the light visible region, because and in case if you're taking an infrared region, we can't see the waves traveling to the television. Suppose we are turning off and on or volume button or channel change, if you want to do so, at that time whatever the button we are pressing, so at that time some infrared waves will appear, but that is not visible to the naked eye of a human. Okay. And further, this X-rays and gamma rays will be determined by the radioactive and X-ray machines. And regarding this frequency also, I have mentioned here, which starts from 10 to the power 5 to 10 to the power 20 frequency. Okay, thank you.